Okay. Thank you very much, John. I really appreciate being here again to talk about what's new in Android security. I think this is my third or fourth time now that you invited me here, and it's really nice. I really enjoy seeing all the folks here and talking about Android. Let's see what we got. First about me, my role changes, I feel like, occasionally when I come here over the years. Right now, I'm the manager of what's called the Android Application Security Research Team. That's a team that's made out of two smaller teams. So the first one is the malware research team, which is focused on upcoming, persistent, particularly bad malware that we are investigating to see what we can do better to detect that kind of malware, to change the platform, to change maybe Google Play policies to protect users. The second team in here is the Application Vulnerability Research Team. That's a team that works with developers on Google Play to help them build more privacy-preserving or secure applications. We have guidance out there in the Android developer docs about common security vulnerabilities and how to avoid them. We have Android Studio linters that are security related that you use as a developer and so on. That's what that team is building. I've been on the Android security team for 13 years. That's a long time at this point. I've seen most of Android, and I'm still pretty excited about that. So for today, I wanted to recap first with a couple of key figures of what we have achieved in the previous year and in the early 2024. Then I would like to talk about two themes actually that are new in the security space or enhanced in the security space for Android 15. The first one is theft protection in private spaces, and the second one, financial fraud and scam protection. So starting with the some metrics and facts about Google Play Protect, which is our malware scanner that we have as part of Google for Android, and then a couple of other metrics that we have in the Android security space. Just a quick overview. For example, last year in 2023, we blocked 2.28 million applications from being published on Google Play because we believe they're harmful, maybe malware, definitely of policy concerns. And I think that makes people appreciate the scale that we operate in, right? We know that Google Play has millions of applications that you can download, but there's even millions of applications uploaded that we believe are in some way harmful that we'd like to block as soon as possible. These 2.28 million applications came from more than 333,000 different developers that we believe are engaged in malware, fraud, similar kind of abuse that is targeted at our users. Then with Google Play Protect, which is also a live scanner on all of these billions of Android devices that have Google Play services installed, every day we do a sweep of all of these devices to see if there are any malware applications installed. And if you sum it all up, that gives us 200 billion annual application scans to see if applications in the ecosystem are malware or not. And then on a maybe more helpful feature, we've also worked with 200,000 app developers to help them upload applications to Google Play, which maybe don't quite request so many sensitive permissions, which are maybe unneeded for the use cases. And so hopefully that enhances user trust and also makes it easier for developers to gain acceptance by our users. Overall, in particular, the Android for Enterprise space is very, very secure. We've only seen 0.007% of Android for Enterprise devices with potentially harmful applications installed last year. I think that's very good. And then, as of early this year, we're also scoring 18 out of 18 points in the A/B test for Android anti-malware products. That also made us very happy. And you'll also see that our security outreach program, where we work with the security community at large, has also been very successful. The trend line for the overall bug bounty or vulnerability rewards that we've paid out at Google seems to be going up. It was 10 million in 2023, of which 3.4 million came out of Android, 2.1 million came out of Chrome, and the rest came out of other products. So let's talk about the first of the new themes that we see in Android 15. And for what it's worth, many of these topics that I will introduce in the next couple of slides in this section, in the next section, are really a combination of platform security features, which is things that are baked in the operating system, but also things that are part of Google Play services. So those two definitely work together. So the first big theme is theft protection. And of course, that's a big theme because I think for most of our users, losing their phone or having their phone stolen is probably the most disastrous thing that can happen. You're out of like hundreds of dollars, maybe thousands of dollars if you have a high-end premium device. And then you may lose access to your phones, sorry, your photos that maybe not be backed up, documents that are not backed up. Or maybe someone can use your phone to log into your bank account and maybe steal your money and so on. And so to address that risk, we have built a couple of new features in the Android 15 that I would like to introduce. So first, we've got theft deterrence, right? I think the ultimate goal for all of this anti-theft work is to get to the point where thieves or robbers don't even try to steal your phone because they know it's kind of useless. And so we're building a series of features into the operating system that helps with that. For example, Android 15 has introduced what's called a refreshed factory reset protection. And if you have that enabled, then if someone factory resets the device and sets it up again, they would also have to know your Google credentials of the last Google account that the device was configured with, right? So if someone steals your phone, they can factory reset it, but because they don't actually know your Google account credentials for the next setup process, they cannot complete the setup process. And so the phone is kind of useless for them. And then what we've also introduced is a couple of settings that are of particular interest to thieves and robbers. They now require additional biometric or PIN or password challenges to disable. So you see in the screenshot on the right-hand side, the Find My Device setting, which allows the device to be located over the internet, cannot be disabled anymore unless you pass another authorization challenge. It's very obvious why, because if someone steals your phone, one of the first things they do is, oh yeah, we're going to disable Find My Device, or we're going to disable maybe your internet connection, or we're going to disable certain other security features that may help you locate and recover your device. So that's not possible anymore. And these features are in particular targeted at situations where someone sees you walking down the street, you have your phone unlocked, they snatch it out of your hands, and then they try to do all of that. But they cannot do it anymore unless they pass these authorization challenges somehow. The second feature we have, and that's kind of interesting, it's called proactive theft protection. It's a series of features that try to essentially understand that your phone has just been stolen and then react to that. And so don't ask me exactly what kind of algorithms are implemented here by our Google AI, but the first algorithm we have is trying to figure out, you know what? Was my phone just snatched for some reason? And then it automatically just locks you out and presents you the lock screen challenge to get back into your phone. Same happens when someone's trying to take the device offline in a way that seems very intentional, maybe as a result of theft, right? And then the last thing we did is also particularly interesting. It's possible, just as a background, it's possible for applications like your bank application or whatever to use the Android OS lock screen authorization to log in, right? What we now do is across all the applications that use the standard login mechanism with your biometric or whatever, we now count how often someone fails to pass the challenge, for example, the fingerprint challenge, across all the applications. And if you fail it more than 5 times, your phone automatically gets locked too, and you're thrown back to the lock screen. And so we don't need actual collaboration from any of the developers of your bank app, your health app, whatever else. Anything that uses the fingerprint or password or PIN challenge that's default on Android is automatically included in that system. And so we can now lock out potential thieves after they fail to log on across different applications. I think that's very, very neat. Then, of course, well, your phone has just been snatched, right? So what do? You go to a friend and you say, oh, can you just go to android.com/log? And then you enter a phone number here. That's the phone number of the device that was just stolen. And then you can very easily and effortlessly log that just through this website. That's very neat. I tried it earlier today for the first time, actually, in preparation of this presentation. It works pretty well already. So that's, I think, an answer to all the people wondering, well, my phone has been stolen. What do I do now? First step or stop for you should always be android.com/log. And then I talked about private spaces earlier in the introduction. And the private space, or the private space, is really a new feature of the Android operating system that's rolling out in Android 15. A private space is essentially a separate space on your phone for applications that's specifically locked behind some kind of authentication challenge, biometric, PIN or password. And you can imagine that if you put all your sensitive applications in there, like finance, health, anything that you don't want anybody to see, even if a thief snatches your phone and the phone is unlocked maybe in the moment, the private space is still safe. It's still locked behind this authentication challenge. And that means hopefully your bank app is secure, your health information is not compromised, whatever else you want to hide from a potential thief or just an eavesdropper really is still secure here. This is a real operating system feature. So it benefits from all kinds of data isolation, app isolation that's baked into the operating system. It's not something that's bolted on top. The second key theme that we have, financial fraud and scam protection. This is a hot topic right now, especially in a couple of countries, or many countries actually, in Southeast Asia. And so in collaboration with a couple of governments, we have developed a deeper understanding of what financial fraud looks like in Asia and how Android can help these people. And it turns out that even though this all started in Asia, it turns out it's really useful. And so we're expanding to other countries too. Next up is South America. Some of these features will potentially roll out worldwide. So let's take a look at what that is. The first one is, Google Play Protect, which in the past was a very simple signature-based scanner, is really expanding its capabilities. And so what we do now is we have an on-device AI agent that tries to analyze how applications are interacting with each other or interact with the operating system. And if our algorithm decides, well, there's kind of a suspicious behavior, we may recommend this application that is under suspicion for additional scanning by our backend servers. We may also warn the user about that. You see that in the screenshot on the upper right hand, on your right side, on top. And that means then essentially that we're not fully reliant on having an up-to-date malware signature database that the device can connect to. Of course, this kind of scanning is potentially sensitive, so it's all happening in what's called the private compute core. Private compute core is Android's machine learning enclave, really, where all of that privacy-sensitive stuff sits. It doesn't leave the device. It's private just for you and your device. Then a couple of features that we have added in response to a particular kind of fraud. And that particular kind of fraud is really social engineering, where a fraudster is trying to get you to install a remote screen control or screen sharing application, and then they walk you through, or even take over your device to transfer some money using your bank application or some other application like that. So what do we do now? The first feature we have is called partial screen sharing. Partial screen sharing allows you to only share the screen as it's happening for a single application instead of your whole phone. So you can easily share less sensitive application screens like I don't even know what that is. But you don't have to share everything. So if you switch apps to your bank app, to your browser to enter a password or whatever, that kind of screen would not be shared, and it wouldn't be available to anybody who's trying to socially engineer you into screen sharing. The second was a prominent status indicator for screen sharing that sits in the top bar on your Android phone, very similar to the status indicator that we already have for microphone access, GPS access, video access, and so on. So you can remember that you're actually sharing your screen, and you see how long you've been sharing the screen already. And the third one is a pretty funny one. So many banks still send you OTPs, one-time pads over SMS to help you log into your account with a two-factor challenge. And if it turns out that you're screen sharing, we're now suppressing that message. We don't actually show the OTP in the message screen anymore, in the notification anymore, because we don't want the fraudster to immediately steal your OTP and log on to your bank account or whatever you're protecting from their device. So you would have to intentionally go to your messaging app now and get that OTP. Of course, only when you're screen sharing. OTPs in general are a rich target for fraudsters, unfortunately. And so we made another change, which I think is also very interesting. In response, and that's some background, in response to us cracking down on apps with SMS permission that steal OTPs, a lot of fraudsters have moved on from SMS permissions to what's called notification listener permissions. The notification listener permission allows you to access the message text of incoming notifications. And if you see a message text for example, your bank app or your SMS app, that may include the OTP that you're supposed to enter. And so what we do now is the notification listener API actually automatically scans incoming notification messages and tries to detect if there's an OTP in there. And if there's an OTP in there, we don't make that available anymore to the notification listener API. So the fraud app that may be on your phone trying to steal your OTP does not actually have the ability to do that anymore using the notification listener API, which I think is a really, really interesting feature. Very similar, we also now protect your credentials as you enter them when you screen share. And that means we automatically detect whether a password field is coming up on your screen. And for the time being, as you enter your password or your account name here in the screenshot, the scammer is just going to see a black screen that's not going to be transmitted anymore. So they can't watch what your keyboard shows letter for letter as you enter it anymore, right? And that doesn't depend at all on app developers. Once again, this does not need any app updates. This is just going to be an operating system feature. Another thing we did is we noticed that a lot of the financial fraud applications that we're seeing in Southeast Asia are actually spreading over side loading from particular sources. That means users use file sharing applications that are insecure. Users are socially engineered into downloading maybe a particular fraud application from a browser, from a messaging app. WhatsApp is very popular. And so if we see that a particular installation flow is file sharing app to side-loaded installation of an application, we're going to throw you a couple of extra challenges where we say, you know what, by default, we think that this is likely a fraudulent installation flow. But if you really want to go through it, if you're really safe and secure in your belief that this is a harmless app that you're installing, go through the settings, enable it. And so we started a pilot to test this workflow and see how users react, see how the government agencies that we're working with, what they think about that, right? And so in Android 15, we have this feature for a couple of pre-selected permissions. That's how it works, right? The side loading flow has to be suspicious, plus the target application that we're installing has to have a couple of permissions, including device administrator, including the ability to display content over other applications, including SMS access, call log access, and a couple of similar suspicious applications. Initial tests seem positive, but we're still in the testing phase on that. And you most likely haven't seen it unless you're in a couple of countries, I guess. And then we also want to help the developers that are actually under attack, meaning most of the time bank applications, maybe finance apps like PayPal, Venmo, Cash App, whatever it is. And so we have this Play Integrity API. And that's not a new API that has existed under one name or another for a very long time. But we've made some changes that are hopefully useful in defense that these app developers may deploy. So the first one is we do better now surfacing Google Play Protect signals to help an application understand whether they're running on a device that is compromised by malware. And maybe if you're a bank app, you don't want to run anymore if there's a malware app co-installed on the same device. But also we now expose information as to whether the application, your own application, is being recorded or controlled remotely in some way, right? So maybe a bank application does not want to be recorded, does not want to be controlled remotely. In that case, you can use the Play Integrity API as a developer. And you can just say, under these circumstances, I'm not going to run. I'll wait for the user to remove these obstacles. And then they can try to start the bank app again. And hopefully then in a more secure environment, and then the application can run without any kind of potential concerns. There's one other enhancement that I actually want to surface because I thought it was neat. That's called Enhanced Cellular Privacy. And I'm not super expert on that, but I'll explain to you what I think it is. So a lot of the mobile connections, or at least in the past, were fairly insecure, right? They had very poor encryption, or maybe no encryption at all. And so any kind of data transmission or phone calls or SMS or whatever it was that was sent from your device to the cell tower, they were up for interception or maybe even for manipulation. And so what we now have is we have a couple of system settings. First one is called Cellular Cipher Transparency. And that means if you're connected to an insecure network that may not be basically up to date on how it encrypts information, then you get a warning now in your security and privacy center for your device. And you see it in the first screenshot, right? In the first screenshot, you can see that the device is connected to a cellular network that does not actually encrypt the connection at all. And so proceed at your own risk, I would say, if you know that. The second setting, Identifier Disclosure Transparency. There's also a concern with a mobile network, but it's a little bit different. You see it in the second screenshot on the right. The idea is roughly that some mobile towers will ask you to send some unique identifiers, for example, the IMSI, it's shown in the screenshot, before there's actually an established secure connection between the cell tower and the device. And what that means is that someone could actually use that to track your phone across town or whatever, because the phone sends at the request of the cell tower this unencrypted unique identifier. And we don't want that, you know, and so we want users that they should be mindful that there are apparently cell towers around that leak your device identifier, which can allow someone to track you as you move around. And then we also have an Android enterprise feature. It's called Disabling Null Ciphers. And the idea is simply that if you're an administrator for a corporate fleet of Android devices, you can just globally disable access to these outdated mobile networks that don't provide any kind of encrypted connections. So you don't have to hope that all of your users continuously monitor if their mobile connection security is encrypted and doing well and so on. So now you can just say, do not connect to insecure mobile networks. Besides those improvements that I've shown in Android 15 security, there's a bunch more actually. I had a little bit more esoteric, so I skipped them. But if you're interested in reading about them, you can already see them on the developer.android.com site. Every version of Android actually comes with a very nice detailed list of all the changes. at I think the exact right level of abstraction. So you go to this website, you go to the drop-down menu to select security or privacy. There's two different drop-down menu items. Then you can read what has changed in Android security and privacy in Android 15. And hopefully later this year, all of you will have a chance to use Android 15 on their phone. It's currently in beta, I believe, so not everybody has it yet, but the rollout should happen soon. And that's it already. Thank you very much, folks.